Okay, so this is a video dealing with asymptotes and limits involving infinity. So for vertical asymptotes, if the limit as x approaches any number a of f of x is equal to plus or minus infinity, then we have a vertical asymptote. So for example, here's a graph, and our asymptote would look like that. For horizontal asymptotes, the limit as x approaches positive or negative infinity of f of x is equal to any number a. So, for example, here's our graph. That would be our asymptote, and for both of these, our number a would be here, and a would be here.
Okay, so a good way to try and solve these is by looking at the highest powers of the variables in the numerator and the denominator. So we'll call those m and n. So if m, which is the highest power in the numerator, is greater than n, that means that your limit does not exist. If n is greater than m, that means that the limit equals 0. So the general equation that we use to solve these is the idea that the limit as x goes to infinity of 1 over x over n, or any number a, x over n, is equal to 0, because as x approaches infinity, this number will get very, very small and essentially equal 0. And you always divide by x to the highest power in the denominator, never the numerator. So, to do an example, in this case, our highest power in the denominator is x to the third. So you want to divide every single piece of this equation by x to the third. So that will give you the limit as x goes to infinity of 5x over x cubed plus 3 over x cubed divided by 7x cubed over x cubed plus x squared over x cubed. So if you simplify that down, you get the limit as x goes to infinity, sort of 5 over x squared plus 3 over x cubed divided by 7 plus 1 over x. So when you put in infinity for this, the 5 over x squared goes to 0, 3 over x cubed goes to 0, and 1 over x goes to 0, so you're left with 0 over 7, which is equal to 0, and that'll be your limit. In this example, we can see that the highest power of the denominator is x squared, so we're going to divide every part of this by x squared. So this will give you the limit as x goes to infinity of 3x squared over x squared minus 2x squared over 18x squared divided by x squared plus 7x over x squared. So if we simplify that, the x squareds will cancel, so you have 3 minus 2 over x squared, and the x squareds here will cancel also, and the x squared. So you get 3 minus 2 over x squared divided by 18 plus 7 over x. And when you put in infinity, 2 over x squared goes to 0 and 7 over x goes to 0. So you're left with 3 over 18, or 1/9. Yes, that.
Oblique asymptotes are when the asymptote is a non-horizontal and non-vertical curve, such as, so it might look like this. if that was our asymptote, here's our graph. So, for example, if we divide by the highest power in the denominator, which would just be x, so x squared over x minus 6x over x plus 7 over x, all of that over x plus 5 over x. These will cancel, just end up with x. These will cancel, that will go to 0, this will end up as 1, and that will go to 0. So you're left with x minus 6 over 1. Now, this isn't your equation of your oblique. It just tells you that there is an oblique. To find the actual oblique, you would need to use long division. For this particular problem, the actual answer after long division is x minus 11. And so, to sum up, the limit as x approaches any number a of f of x, if that is equal to infinity, then you have a vertical asymptote. If the limit as x approaches infinity of f of x is equal to any number a, then you have a horizontal asymptote. To find limit, you divide by the highest power, in the denominator. And that is asymptotes.